Hi guys, welcome back. We're going to continue talking about direct proportions, but there's a special way to solve them, okay? So, if you were to say, okay, we have this fraction, x over 3, and we want it to equal 8 over 1, okay? You would say, oh, well, to get x by itself, I need to multiply both sides by 3, right? So you'd be like, okay, x equals 8 over 1 times 3, so x equals 24. Okay. And that's great if x is in the numerator, that's easy to do, but if x is in the denominator, that's not as easy to do. Okay, so we're going to show another way, but you can absolutely use this way. You can also be like, well, to get from 1 to 3, I have to multiply by 3, so to get to 8 on the top, I need to multiply by 3. Okay, so just recall using fractions like that, okay? So we have what's called the cross product property, okay? And what that is if we have two fractions that are equal to each other, we can only do this if two fractions are equal to each other, we can multiply their diagonals. So we can do a times d, which they did here, and b times c, and those have to equal as long as the bottom numbers aren't 0, which most fractions aren't because we know that that can't happen. Okay, and what I do is I call this the butterfly method because if you look at this, it kind of looks like the butterfly wings. Okay. So this is the butterfly method, and that's kind of what I'll refer to it as for the section. So just to prove that this is true, we know that 2/3 is equal to 4/6, right? Because we can multiply top and bottom by 2 and get the answer. So if I do 2 times 6 is equal to 4 times 3. So now there's no denominators. That's kind of the whole point, is we get rid of the denominators. Well, 2 times 6 is 12, and 4 times 3 is also 12. This checks out, okay? So they've proven that this works, okay, and that this is true every time, okay? So this is just a quick way to solve proportions, okay? And this is what we really take away from the direct proportion lessons, okay? And again, sometimes you'll be able to do some of these problems shorthand, but I want you to be able to do it this way because sometimes there isn't a shorthand way to do it, okay? All right, so Rachel paid $40 for 8 t-shirts at a store. Given that the cost is directly proportional to the number of shirts you buy, you can use proportions to find the cost of 5 shirts. Now some of you are going to be like, Miss Hawes, I already know it's 25 because 40 divided by 8 is 5 and 5 times 5 is 25. Great. I'm still going to show you this other method. So I know that the cost over the number of shirts, okay? So I know the original cost is $40 over 8 shirts, and I want to know what the cost is for 5 shirts, okay? So notice I have the cost on top and the number of shirts on bottom together. The cost of 8 shirts is together and the cost of 5 shirts is together, okay? So direct proportions work very well when we have 3 pieces of information, 3 numbers. So I'm going to multiply across the top, I'm going to multiply the diagonals, okay? So 40 times 5 would be 200. Equals 8 times x, which is just 8x. Again, I set the diagonals equal to each other, okay, so we can solve for them now. And then I would divide both sides by 8, and that would mean x equals 25, and this would be $25 would be my label. Okay, and again, for some of you, you're going to be like, well, I could have figured that out without direct proportions, and that's fine, but again, sometimes that won't work for you. Okay, so that's why I show you this method. All right. Let's go ahead and try this one. So it says Gretchen works at a convenience store. The amount of money she earns is directly proportional to the number of hours she works. Okay, so she is paid $432 for 18 hours of work. Use the proportion to find out how much Gretchen has paid for 21 hours of work. So again, some of you are going to be like, well, Miss Hawes, duh, why don't I just divide and then multiply? Again, you can, but sometimes that's not super helpful. So we have the amount she is paid over the number of hours worked. Okay, so I'm going to have 432 over 18, okay, must equal X amount of dollars she makes in 21 hours. Well, again, I'm going to use butterfly method. So 432 times 21, which would be 9,072, equals 18 times X, which is just 18X. And once I have that set up, now I just divide because it's a one-step problem. So this would be $504. Okay. All right. So the next one, we have number of crates and number of peaches. Okay. So I know in 15 crates there are 600 peaches, and I want to figure out how many peaches, or I'm sorry, how many crates have 1,000 peaches. So again, this is basically set up as a direct proportion already. So I'd have 15 over 600 is equal to x over 1,000. Okay, and then I multiply the diagonals. Well, 15 times 1,000 is 15,000, equals 600 times x, which is 600x. And then I would go ahead and divide that. And 15,000 divided by 600 is going to be 25. So this takes 25 crates to get 1,000 peaches. Okay, so go ahead, I want you to try and see if you can figure out how many peaches are in 56 crates. So I could use, oh, I should mark that. Okay, so I could use the first fraction, or I could use the fraction I just found. I typically will go with the first fraction just because in case I made an oops here, I don't make an oops on my second one, okay? But if you use the 25 over 1,000, you should still get the same answer as me. So this time I'd have 56 over x, okay? And then we'll do 15 times x, which is 15x, equals 600 times 56, which will be 33,600. And then I would go ahead and divide by 15. Which would be 2240. So I get x equals 2,240 peaches. Okay? All right. So this next one, this is where students have some issues occasionally. Okay? So it says, when they say that x varies directly as y, that means y is directly proportional to x. So they basically are changing the wordage, because remember when we talked about y is directly proportional to x, we know y is our top number and x is our bottom number. So when it says varies directly, we basically flip-flop the top and bottom. Okay, so just remember that you already know how to do this type of problem, they're just changing the wording. So like if I said m varies directly as n, okay, this is my bottom number because this varies directly instead of it is a direct proportion, and this becomes my top number. Okay, so if I need to find my k, which would mean n over m, which in this case would be 7 over 21, which is 1/3. So this is my k value, my constant proportionality. So then I can write my direct proportion equation, and the top number is always my first variable in my equation. So it'd be n equals 1/3 m. Okay, and that makes sense because if I plugged in 21 here, 1/3 of 21 is 7, so that works out. Okay, so you can kind of check your work with the two answers they gave you. All right, I hope this video finds you well, and we'll talk to you later. Bye.